Hello, hello. Sorry, I have like two different mice and a cell phone on my mouse pad. I'm trying to shuffle things around so I have enough room. Welcome back. First of all, are we live? Callie's alive. Okay, looks like I'm live. Is my mic working? Okay, cool. That took longer than usual. Alright. Welcome back to Advent of Sintran. Today is day 16. No more midnight streams. This is the week. This is a weekday. It's not the weekend anymore. Can't be staying up till midnight. So let me download my input. I did catch a glimpse of the input for today's puzzle, so it looks like it's another grid problem. That's all I know. I haven't seen the puzzle text at all. And yeah, that looks like a grid. I'm not going to zoom out because I like my font size. And okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, that's too much to count. Oh, I'm almost there. Okay. 140 by 140. I see an S. Whoa, what did I do? I see an S and an E. Oh, it's a maze. It's just a maze? There's got to be more to it than just a maze. Okay. I think that's the font size that I had. Got to resize that Tmux pane now. Alright. What is this puzzle? Reindeer maze. So we start facing east. Here's the sample input. That's 15 by 15. 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Increasing. Okay, so moving is. Oh, are we trying to like maximize the path? So same maze but different path? No, it's a different maze. Because we don't have these three. We don't have all of those hashes. Okay, so we want the lowest score. So moving costs 1 point. So we kind of want to minimize turning. Turning is much more expensive than moving. So is a 180, well, you would never do a 180. There's, like, if you start backtracking, there's no way that would be optimal if you're trying to minimize the score. So it was like, is 180 2,000? But you're never going to do that, so it actually doesn't matter. thinking about this, but let's at least edit the template. Okay, so I can read the input and echo it line by line. So can I do a depth first search and just find all the paths and minimize it? So it's 140, it's actually 141 by 141. It's not a round number. Like, can you do a depth first search? Will that be optimal? You can find, I think there was another maze problem last year where you could optimize it by having a graph of not all the positions, but all of the junctions. Right, like a place where there's a fork in the road and you have a choice of whether to turn or move one way or move the other. You have a choice of backtracking or going in one direction or going in a second direction. So basically 3 different directions if you count the backtracking. But right, because like if you only have 2 choices, it's not really a fork. You're going either forwards or backwards. You can't really fork. So you could make a graph of only the junctions, and then searching through that instead of searching through every position in the maze was a lot easier. What does the test input look like? So I think that would work here if we have to optimize it. We could probably just brute force part 1 though. I don't know. It's day 16. Maybe that won't work. So, like if I do a naive depth first search, another option is maybe doing something like A star. Except I think A star doesn't find the optimal path. It just like uses a heuristic and it finds a good path that's not necessarily optimal. Or maybe I'm thinking about a different algorithm. And then there's Dijkstra. But Dijkstra is basically depth first search. Unless, I can't remember what the difference is. Dijkstra is like depth first search with one other thing. Or breadth first. I forget which one it's more similar to. But I think if we need to optimize it, we can only search the junctions. So like this would be a junction because you can go right, or you can go down, or you can go up. And then this is not a junction. Like you can turn, but you only have 2 choices of where to go. You don't have 3 choices. Here's another junction. Do we have any junctions with 4 choices? I don't see any here. But yeah, basically as long as the paths are sparse enough, I think the graph optimization should help. If you have hashes along the walls and then dots filling in everything with no hashes in the middle, then that's kind of like a dense graph. Or if you search the graph, you're just doing the same thing as searching every single dot because every dot is a junction in that case. But I think this is sparse enough that would help. So let's try brute force, and then if that doesn't work, we can think about optimizing it like that. Okay, so I'm gonna want to load. I need a function that's just like load character matrix from a file, and I need to put that in my utils. So let's do that. Read char mat. So it's going to take a file name, and it's going to return a vector of strings. Basically, or not a vector, but a matrix of strings. Basically, it's a matrix of characters, but I don't have a character type. I'll just have strings of length 1. I'm not going to use a while loop. This is already a global variable. It's about time that I made a function for this. I've been rewriting this, not every day, but like almost half of the days of Advent code. I've written this exact chunk of code over and over again. Does that work? Okay, there's a matrix of characters. They have comma delimiters in there. I think I made a function yesterday that will print this without the comma delimiters and the space delimiters. But don't always bother with that. Yesterday I I had to do a lot of debugging, so I was looking at a lot of character matrix output, so I finally made a function to do that. Anyway, this should go in utils, actually. So let's put it in here. Okay, and then I'm including that utils library, so that'll simplify my life. If I remember that I have a function there, it's just f. Yeah, and now it's not the global variable, so now this is yelling at me. Although it really should be file name. There we go. I don't know if this function even needs a comment. I think I just ran that, but why not run it again? Okay. Now I need to find, first thing to do is find the start and end points. The downside of doing this in a function is that I don't have variables for the size of this thing, so I have to get it. You could return multiple values from the function, but it's only 2 more lines. So if chars xy, I think it's capital S. It's capital S and capital E. All right, 113 seems legit. Now, depth first search, right? So when was the last time? Not the last time, because I I used a stack yesterday, but that wasn't really a search problem. Day 12. I don't need every instance of stack. How about just the stack declarations? 10, 12, 15, and 5. 5 looks like a sorting algorithm. Why the hell is that inside? Yeah, because I had to implement a sorting algorithm that wasn't based on less than and greater than. It's based on some other weird criteria. Okay, so like I said, I did one yesterday on day 15, but that wasn't really a search and definitely not a grid search problem. This is a grid search. You can kind of tell because it's a two-dimensional stack, 2 by some capacity of the stack. So I think I want to steal some stuff from day 12. Yeah, we're gonna have visited. We're not gonna have ever visited. That. Oh, yeah, this was the garden plot day. So we're not gonna have that thing. And we were resetting this on every iteration. We're not going to do that. Basically, there's only going to be one iteration. We're not even going to have a loop out here because we're starting at the start. We don't have to like iterate over different start points. That's what day 12 did because you had to flood fill each plot or each vegetable or like whatever they called it. I can't remember. Okay, so we don't have that. We don't have that. That's not going to be our answer. So we're going to push, well, before we pop, that was popping that I highlighted. Before we pop, we have to push. We're not pushing this. We're pushing the start location. And we don't have area or perimeter. I think this should work. Not going to have that. We are going to have directions, so I have to copy that. How do I keep track of which direction I'm going? Like, how do I add up the score? That's going to be something to think about. Do I need to... I think I need to push my direction onto the stack too. I think I have to push. It would be nice if I had recursion, and then I wouldn't have to manage all of the state on a stack. But I don't have recursion in Syntran, so I have to think very carefully about what I push and pop onto and off of the stack. So we're going to want to find the shortest path. Would it be easier to do this with bread first? Because then as soon as you... No, because we have this scoring algorithm, which is not the length of the path, it's something else. It's the length of the path plus how many turns you make. So I think I have to push X and Y position onto the stack. I'm already doing that. I think I have to push my score onto the stack, which is kind of the length, but plus 1,000 times the number of turns that you make. And then I think I have to push the direction onto the stack so that I know if I've turned or not. Because when you do like a stack-based depth-first search, you don't really know what last point you were on or which direction you were facing previously. You're operating on a stack. So you don't really know where you were. It's not really a chronological search. Like you'll go all the way down through the depth of one path, and then if you get to the end of that path and you hit a dead end, then you just like jump back to the last fork that you can make. So you don't really, the last point that you were on in the search isn't really the last location that you were chronologically, because you're like jumping around as you do the search on the graph or do the search through the stack. So I think we have to push all of that state onto the stack. And that means it's not going to be 2. So we have X, Y, score, and direction. So that's 4 things. Direction. Excuse me. Okay. Score and dir. Let me get this lined up. I had an experience with CLang format today at work. It does not let you do this. It will take this code and it will change it to that, which just looks like shit because they're all coming from the same stack. So I want these things, I very much want these things to align. Oh great, now I fucked it up. I very much want these things to align vertically. And then like if I edit, if I change the name of this for something, I can just do it with column editing. But CLang format is like, no, fuck you. You can't have extra spaces on either side of an equals sign. So no, that's wrong. Fuck you, CLang. You're wrong here. Hey, Juice Mit Elpfern. Yeah, I do play music. Why do you think I look like I play music? I'm curious. I to like look behind me, I thought maybe I had a guitar hanging on the wall, but not in this room. You read my website. Yeah. That'll do it. How's it going? Are you working on Advent of Code? Did you finish today's problem yet? I think this is all the stuff that I want on my stack. And then when I push, I have to push all 4 of those things, not just location. We're going to start with a score of 0, and we start facing east. So I think I want to enum for that. Oh, you got day 11 part 2. Yeah, day 11 was hard. I think that was one of the hardest ones so far. Yeah, I mean, I got lucky this year. Somehow I'm keeping up, doing everything on the same day, but yeah, there's no reason to do these in any sort of timely manner. Okay, I think I want to know which direction is which. So this is west. This is east. This is north because y up is south. So negative y is north. It might seem backwards, but that's the convention that I'm using. So then that's south. And then I want to have magic numbers for these. And these values will work as indices into this array. I think I did this maybe 3 days ago. Instructions. No, that was yesterday. except we had instructions, which were like angle brackets and the caret and the V, but it's the same idea. 2, 3. West, east, north, south. I want to make sure I got that right. So negative x, west, then obviously east, and then y, negative y is actually north. Yeah, I think that's right. So I think we start facing east, so that's the first thing I want to push on my stack. Okay. So I wondered about that. It's good that they clarified this because you start facing east, but if your first move has to be north, then you actually have to turn, and that changes your score. But that's not the east I was searching for. Well, it's the same thing. You start facing east. Do you have to face any particular direction on the end tile? I think not. I think you can get there. I'll figure it out when I try to match these scores. So I assume you would end facing north, and then you don't have to turn. And then in the second example, well, it's the same thing. So that's not really a good example if they both end facing north. Yeah. Okay, so I have to push 4 things onto my stack. Why Fortran? I use Fortran at work, so I'm probably better at Fortran than I am at any other language. I do like it. It's not like I'm forced to use it at work. It's pretty good with arrays. I also, one of the first languages I learned was MATLAB. At my university, they made us learn MATLAB. All of the engineers, like mechanical engineers, had to learn MATLAB. And MATLAB is kind of similar to Fortran. Yeah, MATLAB is weird. But it started me in that direction. So transitioning from MATLAB to Fortran is not so bad. MATLAB is not great. It's not free, first of all, and then it's an interpreted language. So is this, but Fortran is compiled, so Fortran performs very well. Makes it a little bit harder to learn than MATLAB, but a lot of the array syntax is very similar in MATLAB as it is in Fortran. I think that's all the stuff I need on my stack. Now I have to keep score. I think I just copied and pasted all of this searching algorithm from another day. So I think that'll work. Still need a bounds check. And then, yeah, we still have perimeter code in here. That doesn't apply to today. Now we have to keep score. So, I think if you revisit, so we're never gonna have a 180-degree turn. So I never have to add 2,000 for a turn. I'll only have to add nothing for turning or add 1,000. And then this is where I push, so that's not going to work. I need more things on this stack. So we need X, Y, score, and dir. But I don't want a 2-dimensional direction. I want like a 1-dimensional encoding of the dir. I want one of these things. So I don't want this. That's a 2-dimensional direction. I want this as my direction. And that's ID instead of dir. Cares. Yeah. Well, this isn't even Fortran. This is my language Syntran, and the interpreter for Syntran is written in Fortran. So this is kind of related to Fortran, but it doesn't really look anything like Fortran. dir. So this was the previous direction that we popped off the stack. We have the score, and I don't want this, but I do want to check that I don't go into walls. So if chars xn, if it's equal to a wall, then we continue. I think that'll work. And I still need to score. So moving forward is 1. And turning is 1,000. So if our current direction is not the previous direction that we popped off the stack, then I also have to add 1,000. And moving in a line is just 1. So if ID does not equal dir 1,000, it's 1,000, not 100, right? Okay. I think that's it for the search. And we also need to know what is the end. I want to find every path. Will this find... Oh, for advent of code? Well, I'm committing the input too, so most of the lines are that. So day 15 is weird because I did part 1 and part 2 separately. Usually I do both parts as one commit. So when did I do that? I think for day 14, I made one clean initial commit. So it says 758 lines, but that's not all code. That's data and code. If you just count my code, it's 250 lines. And that's somewhat typical for an advent of code day in this language. So I think I don't want a visited array because you might, throughout the whole search, you might traverse some points multiple times. Like these are 2 different examples. So they only show you one path, but in the course of getting to the end, we should hit the end like twice. Are there at least 2 paths? Yeah, there are at least 2 ways to get to the end. So you should get to the end twice. So I don't want to like skip revisiting points that I've been to, because I want to find all of the paths and then find the optimal path. But that means I can't do... How do I not do infinite loops then? I've done this before in Advent of Code, haven't I? Like last year. Not this year yet. But how did I do this? Does it have to be... Again, I don't think I want breadth first search, because you don't want to find the shortest path. You want to find the path with the lowest score. And that's not necessarily the shortest path. have to look this up. It's day 16. I'm not going to get through these last 10 days without Googling stuff. Shortest path. Right, you have like a dist of infinity. Then you have previous. Right, you need like a min heap to do this efficiently. And this is a Q. So I think the letter Q means like Q-U-E-U-E. So it's basically a Q. It's not a queue, it's a min heap, but it's kind of similar to a queue data structure. Dijkstra versus breadth first search. So BFS is a queue and DFS is a stack. And then when can you not just use breadth first? Just, yeah, so like a weighted graph. When you have a weighted graph, you need Dijkstra, not BFS. But do we have a weighted graph? I'm not really sure. We have this weird rule where when you turn, that's 1,000 points, as opposed to moving, which is 1 point. So I think that might make it a weighted graph. Is that a joke? I think like some people try to do it without Googling. It's not cheating. Like some people do this with AI. I don't know. Like, yeah, like sometimes I get stuck and I want to look something up. Yeah, I don't consider that cheating. I would consider like doing everything with AI to be cheating, but I think you can Google. And here's the thing: if you have to stop and Google, you're probably not going to make it onto the global leaderboard anyway, because those first 100 spots are going to fill up before you have time to Google and read anything. So I think I might need Dijkstra. And I've done that last year. I did Dijkstra a lot before I found out that a lot of the time you can just do a breadth first search and it's the same as Dijkstra as long as you have an unweighted graph. So it looks like I used this in day 17 and day 23 last year. I think I might steal from that. Oh, yeah. And then I said, graph is unweighted, so BFS is sufficient. Yeah. Yeah, I do the same thing. Like I'm doing DFS here, which is similar to BFS. It depends where you put the recursion, and then I don't have recursion, so I'm using a stack instead of recursion. But like you can put these types of statements like at the top of your loop, or you can put it at the end. So yeah, there are different ways that you can write it and still have an equivalent algorithm that gets you the same answer. Okay, I think that was day 23. 2023, day 23. Is that not here? Oh, and like main V2. I don't know if that even worked that day. Let me look at one that's not commented out. So day 17, I had it for real. 17. Okay. I think I'm going to steal this instead. This is before I had continue statements in Syntran, so I did stuff like this where I had a boolean continue. So maybe I want to steal this and refactor it, or is it easier to just re-implement Dijkstra from scratch? Like, look at all this nesting because I didn't have continue. It's terrible. What is map here? I had a pop function. I think it's just easier to implement it from scratch looking at this than it is to take this code and adapt it. Unvisited. Still in queue. What am I doing with unvisited? That's not in the Dijkstra pseudocode. And then the tricky part, to do this efficiently, you want a priority queue or a min heap or some data structure like that. Like Fibonacci heap or a Brodel queue. Those are priority queues. Is this not the same thing? Yeah, the tricky part is doing this efficiently, but the brute force way to do it is to scan the entire queue and just find the one with the minimum distance. With a fancy data structure, you can do that faster than you can by scanning the entire queue every time. Do I have any interesting design choices around my language? It's good with arrays. So let me show you the Syntran Explorer. I'll put this link in the chat. So this is a website where you can run Syntran in the browser. You don't need to install anything. In case you could cache the scanning. Yeah, that's probably right. So you can run this in the browser, and then it has different samples here. So hello world is simple enough. It's just one line. It's pretty similar to what you'd see in Python. But then I think arrays is where this starts to get interesting. I don't know if other languages can do something like this. So first of all, there's slicing. Like we have a matrix. It's a 3x4 matrix, right? We have like 3 columns and 4 rows. The size is right there. Everything above the size is the data in the matrix. And then you can slice this. Languages like MATLAB and Fortran can do this. Like if you want to pull out a row of the matrix, you can do it like this. So this is an X slice, and then you get 0, 1, 2. It's just that first row, or row 0 of the matrix. And then if you want a column, you put the colon in the other place. So this is column 1, which is 1, 4, 7, 10. And then it prints that down here. And you can also do 2-dimensional slices. Again, MATLAB and Fortran can also do this. So this is rows 0 through 2, and then columns 1 through 4. Rows, no, it's columns 0 through 2 and rows 1 through 4. So then you get like a rectangular subsection of the matrix. So 3, 4, 6, 7, 9, 10. It's just these values, but not the first row or the last column. And Fortran and MATLAB can do all of that stuff, but what I don't know, I'm not aware of any other language that can do this. You can then do a compound operation on a slice of a matrix. So what this does is it takes, which one is this? It's column 1, so 1, 4, 7, 10, and then it adds 100 to them. So Fortran actually does not have the plus equals operator. MATLAB doesn't either. The one language I don't really know is Julia. So Julia is another good array-oriented language. Maybe it does have a plus equals operator. I've installed it. I played with Julia for about 5 minutes. So how do I do variables? Does this not like echo? Oh, yeah, semicolons. Why did they copy this from MATLAB? So in MATLAB, if you type something, it echoes the answer. But if you put a semicolon at the end of the line, it doesn't echo the answer. So I was like, why is this code not doing anything? I think that's a really stupid feature. Apparently, Julia copied that. So can we do that? I can't remember how to do. I just want to see plus equals. So x is 3, and do we have plus equals? Okay, Julia does have plus equals. So Julia can probably do this too. I just don't know enough Julia to confirm that. I forget how to do an array. I think I can just do an explicit array, or maybe they don't have commas. Okay, so we have a 1x3 matrix. It's actually not a vector, it's a matrix, even though it's a vector. Why would you call this a matrix? That's another anti-pattern that MATLAB came up with. Anyway, can we do that? Nope. Maybe we can do plus equals another matrix. Can I do v plus equals v? All right, there we go. That works, but you can't do it with a scalar. So I guess I do have more features than Julia. Maybe Julia would consider that a bug, but I think it's very useful to be able to do sometimes. Okay. Yeah, well, in Python you have to use NumPy, so it's not really built into Python. You have to import some library. Yeah, Python does have pretty good slicing when you use NumPy, but it's not really built in. Okay, so I think I want to implement it from this pseudocode instead of copying my implementation from last year that didn't have continue statements. Where am I? Here we go, 2014-16. Okay, so I'm just going to comment all of that out for now. No, I have not tried Ruby. I've tried Python. I guess I installed Ruby because there's this thing called vimgulf. Is this it? Yeah, so to run vimgulf, you have to install gem. I think gem is part of Ruby. So I installed it so I could do this, but I never really used Ruby at all beyond that. I don't know what other languages are like Ruby. Is PHP like Ruby or Perl? I haven't used those either. Probably not PHP. Maybe Perl. Oh, Elixir. No, I haven't used Elixir. Readability wise, yeah. I, I've like never even looked at it. I should. There are so many languages out there. I can't learn everything that I want to learn. Okay. So we want to start out with some infinities. Oh yeah, yeah, I probably could read it partially without having to learn too much. Okay, so infinity is just going to be a big number. Excuse me. And then I want to start every vertex with a distance of infinity. Infinity, and then it's how many vertices do I have? I think it's going to be a square array to match the input grid. How did I do this before? Dist. So it also had directions in it. Yeah, I think it needs to be the same size as the stack or the queue. So I think it needs... Why is it enders plus 1? That's weird. Yeah, I think there was something funny going on with day 17 last year where I had to do enders plus 1 for some reason that I forget. But I think it can just be enders. And then... oh, and then this is like the capacity. How did I call this? 4. Oh. Oh, I remember this problem now. There were weird rules about how long you could go in a straight line. And that's what len min and len max are. So I don't think I need that part. Okay, so dist, then previous. What did I do with previous? I think you don't need previous unless you're backtracking out the whole path at the end. Yeah. So if you only want to know the distance or the score, you don't really need this previous data structure. Okay. So we have distances, and then this is initialized. We don't need to like do a loop for that. And then add everything to the queue. So I need to loop for that. And then so every y, every x, and then every direction, because the distance has our directions in there, and the queue has that. Do I need the score in here? So we're not going to have a stack. Not making a lot of progress today. I've been at this for an hour, and I've just added a bunch of code and then commented it back out. Okay, so you really only have to push the first point, or the starting point. You don't have to do that in a loop. This does not apply to today. Okay, so what is this? It's actually XS, X start, Y start. We start facing east, and I think that's it. Then I have to push that. But pushing, okay, it checks for overflow. It is good to make that a function. What do I do with Q? I think Q is just a global variable. Yep. I didn't have pass by reference back then. I just added pass by reference like 2 days ago. So I could do this without global variables now, but I think I'll just copy this. Had this here. Wasn't it 4? I said 4 XY score. I don't think I need to keep the score in here. So it's really just 3. Hopefully that's big enough. We'll find out. Okay. I might not even use this. I could just do this in one line. And then I'm not going to bother with sorting the queue, at least not at first. Okay, so we have push. I think I need pop as well. Yeah, because pop does the linear scan to find the thing with the minimum distance. And then I guess I do need distance in the queue. So that changes my state. It's the score. So that's 4 now. There's no reason this has to be like this, because then when I change the number of state variables, I have to add an extra line there. But yeah, I can just set the whole array with a slice here. And then push should also do that, actually. Okay. So now I can finally push. Yeah, I've kind of said this already, but I think the biggest thing is the array orientedness of it. So I could just write a line like this now. Maybe I didn't have this feature last year, so I had to... You could do it with a loop. A loop would be better than this mess from last year. Honestly, well, that's salesmanship. The biggest thing about my language is it's just a toy. It's just something for me to play with. It's not fast. It's not, so there are no good applications for it. It's just something fun for me to play with. The main thing that I use it for is advent of code problems. I've written a few other samples in it, but a lot of the code that I've written in Syntran is just advent of code last year and this year. Okay, so what do I want to push? Oh, any language. It depends on the application. Yeah. Like for web, JavaScript, TypeScript, that sort of stuff is okay. But if you want something that is fast, that JavaScript is not great at performance, so you'd probably want a compiled language if performance is a factor. So it really depends on the application. Dist. Okay, and it's still hard to keep track of what's in my state. So I'm pushing score, position, and direction. Score, position, and direction. So this is really XS and YS. Okay. And the initial score is 0. And then we iterate until the queue is empty. What am I doing with found here? So while queue begin is less than or equal. So they start out as equal. And then as soon as you push one thing, the end of the queue gets incremented. So I think I want less than. And that's while the queue is not empty. And then we pop. That removes u from queue. That's all done in the pop function. Then we have to unpack this stuff from the array. You don't have to, but for readability. So the queue is score. Let's call it dist, because all of the literature about Dijkstra's algorithm, they call it distance. They don't call it a score. But it can be like a pseudo distance. It's just a sum of weights on a graph. And then we have direction, but we don't have this because we have one less state than in last year's advent of code graph problem. This is just printing a progress bar, basically. Then I think think I don't need unvisited. This is overcomplicated. It's kind of like the same thing but twice. For maintainability, that's tricky. I think in the end, everything turns into a big ball of mud, no matter what you try to do to stop it. Where's the... Is it this thing? I haven't even read this whole thing, but I've read a few paragraphs out of it. No matter what you try to do to stop it, any system is going to become a big ball of mud in the end. You can try to have standards and try to follow best practices, but maybe if you're working on something by yourself, you can succeed at that. But if you have like a rotating cast of developers who come and go and leave the company, there's really nothing you can do to stop it. I don't know. Are there successful projects out there? Like, I don't know. If you look at something like Linux, well, Linux has like millions of lines of code. Is that maintainable? I don't know what would be considered a good example of something that's maintainable. I think it's easy to start things as maintainable, but yeah, as they increase in size, it gets harder and harder to keep it maintainable. Okay, so we've done this part. Let me move that up here so I don't have to look at it. Now we're in the while loop, which is this. So we pop the vertex, and then we want to visit the neighbors. Still in queue. I think I do need a visited array. Because when you remove something from the queue, you're basically marking it. Where is this? Yeah, right after you remove something from the queue, you mark it as visited or not unvisited. So I think I do need this. And that's the same size as the distance array. It is. I don't want to call it unvisited because then there's an extra negative. I'm going to call this visited and flip all of the booleans. So visited, it's going to start out as false, not true. I think that's easier to think about than unvisited. And it's the same size as the thing right above it. And then when I pop, so pop actually does this redundantly. It marks things that are removed with a -1. So this is like another way of saying if it's visited or not. So it's redundant, but it makes my life easier because I don't have a proper priority queue. Then where do I want to mark that in the other array? I think I can do it right after popping. I guess I want to unpack. Okay, so if we've already visited dist x naught y naught dir, then we continue. And I have a continue statement now, so I can do this more cleanly than last year. So that's basically what this is doing. Score XY direction. Okay, I wanted to make sure I had these in the right order. It's the same order that I pop them or unpack. Now I iterate over the neighbors. And that's looking at every direction. And this is also where, see, here's the thing about being able to write searches in different ways. I need to check that I'm not running into a wall. Right, like we have these hash marks that we don't want to go into. So if you have to check that you don't go through those. And I could put it right here, or I could put it inside this list. The question is, do I want to bother pushing these onto the queue at all? It might be more efficient if I put it inside this loop and then don't push them onto the queue. You could push them onto the queue and then put the guard somewhere around this line, and that would also work, but I feel like it might not be as efficient. So I'm going to check that here, and there also has to be a bounds check. So did we have this here? Yeah, we had a bounds check here last year. So we have to check for bounds and walls. So if not in bounds 0, 0, yeah, I want to know what position I'm on. Are these, yeah, these variables should be okay. X, Y, and then the upper bound is NX, NY. So if we're not in that range, continue, and then we can check if we're running into a wall. You don't want to check the wall first because then you might try to index the characters array. So this was an hour ago, but I have this array called characters that shows where the walls are. And you have to check the bounds before you index into that array. So if chars x, y equals a wall, then I continue. Yeah, it would work. Basically, if you put this check up here and then you change the x, y to x naught, y naught, but it might perform better if I put it inside this loop and then never push it onto my queue. So then I think we have to add up the score and then push. it's the previous distance or score plus 1 for every move. And then we also have to add the turns. So I'm just going to steal it from there. But the variables are named differently now for no good reason. I think I came up with better names this time. So if dir does not equal dir 0, then we add another 1,000 because there's a penalty for turning in this puzzle. And then I think I can push that. I don't know why I'm going so slow today. This might be an only part 1 day. If I can even get part 1. This is taking a while. Okay, then I can finally push. So how did I push the first point? It's like that. Except the score is now not 0. It's not score, it's dist. And then x, y, and direction. Direction is just encoded. It's 0, 1, or 3. Or 0, 1, 2, or 3 for north, south, east, or west. In some order. Probably not that order. That might be it. And then do I just get the minimum distance? That's what I want to, or the minimum score. So how did my Dijkstra work last year? So we have a whole array of distances. Then dist end. I guess I can do it with another variable. Yeah, I need to check the end point. Should I just make one pass over the array? I guess I can keep track of it while I do the Dijkstra iteration. So start it as infinity, and then if you ever see the end point, then you can update it. I think there are multiple ways, maybe not in this problem from last year, but this year there are multiple ways that you can get to the end. So we want to track the minimum one. Okay. So maybe it's important that I do this before the visited continue. So if we're on x end and y end, and then it doesn't matter which direction we're facing. I think that's the whole condition. Then it's going to be the min of that with dist not. Is that it? And then that's going to be my answer. Okay, so sum is dist end. It's probably not going to run. I probably have syntax problems here. Lots of syntax problems. Oh, yeah. Last year I did not have return statements, so all of these need returns. This doesn't return anything. It's just a void return, but we still have to say return at the end. And then pop does return something. We're just going to return x. Dist infinity. Let's call that dist infinity. All right. Visited. How big is visited? What's the rank of visited? NX, NY, enders. So this is in my queue. I don't... do I want that? I'm still not sure how this is supposed to work. And then you have to like guess how big that array needs to be. Question is, will this search every path? Or will it like see some point that's already been visited and then abort searching on a path that might be optimal? Okay, what's the next issue? NX, NY. Some of those are, I think they're both I-64. We can just cast them down. Okay, score 210. It's dist, not score. It's the previous distance plus 1, and then if we turn by going in a different direction, we add 1,000, another 1,000. So that's not going to be fast. And this is the test input. I think I probably have an infinite loop. Is that right? 8038. I think it might be. Nope. Okay, so maybe I do need that extra dimension in the visited array. We have two different examples here, so I think the one that I'm running is the first one. So I think that's the answer that I should be getting. But I'm not getting either of the example answers. Let me back that up because I'm about to, at least it compiles and runs. That's something. That's some kind of checkpoint that I want to back up. So I think maybe I do need this. Do I have like a max length? How long did that take to run? 10 seconds? That's not terrible. It felt like forever. What kind of capacities did I have here? So dist is in the state. It's in the queue. But it's not in this visited array. So the first thing that we push onto the queue, it doesn't exist in the dist array, and it doesn't exist in the visited array either. I think I need to refill my water, so I'll be right back. All right. What did that window just do? Okay, now it's back to the size that it was. Weird. All right. So I'm not actually saving the path because I left out this previous data structure. Do I need to do that to visualize my path? Because can I debug this without visualizing my path? Excuse me. So you have X naught and Y naught. That was the last thing. That was the last location that we were at. That's what we popped off the stack, or off the queue. I keep saying stack, but I mean queue. Similar data structures, but they are different. They're not. Oh, that's not right. Why did I have that? I don't know how that works. Why did I do it like that last year? Was there a reason to do that? Last year was not just a regular maze. Today is just a regular maze. We have a weird score-keeping algorithm, but we can move through the maze freely. Last year there were like weird rules about when you could turn. You had to go at least 4 steps and less than 11 steps straight, and you couldn't turn if you were in a straight line outside of that range. So maybe that's why I had that funny, the previous direction instead of the direction that I'm iterating. How did that even get to the end? Did it get... Like, I didn't return dist infinity, so I don't know how I got to the end. I guess I did. This will hopefully be different. What did I get last time? Like 80, 38. Hey, is that the right answer? That's the right answer. Let's try the real input. It's kind of slow. So maybe we need to find the junctions to optimize this, but I think maybe I can... Let's start it and let it run for a few minutes at least. Let me make sure I didn't change anything. Before I commit to running something for possibly like 10 minutes, I want to make sure I still get the right answer for the test input. Okay. I'll let this cook. There's one easy thing, relatively easy thing that I can do to optimize it, and that's I don't have a priority queue data structure, but if you just sort the queue every so many iterations, then you can really speed up the queue scanning, because then you can look at the first thing in your queue, and then you can also look at whatever elements are at the end of your queue that you've added since the last time that you sorted it. And then like every 100 iterations or every 1,000 things that you push onto the queue, you can sort it again. So I had that last year. There's this variable QEndNot that keeps track of the end of the queue when we last sorted the queue. And then I actually commented this out. I said, apparently I was sorting every 3,000 iterations. Then I sorted the queue, and then that speeds up the scanning. Yeah, but let's let this run for, I don't know, a couple minutes. And then I also had like a progress logger. Might want to put that in so that I can see if this is doing anything. I might give it one more minute and then add a progress logger, because it's hard to tell. You're going to get to the end. You just don't know if you found the optimal path to the end. So we can like print the best distance that we've seen so far, and hopefully that will like stabilize at some point. What was this? Okay, yep. So I had a progress logger here. Greater than. Okay, let's set that up at least. I know it's infinity plus 1, but I'm working safely below the limits of my 32-bit integers. So I can do infinity plus 1. Should log something. Okay, it's been a minute. I think it's been 2 minutes. Let's at least see if this finds the end. Okay. Hasn't found the end yet. If it... Oh, that's 2 million. That's not even too... That might not be big enough. Let me do that. So if it prints another one of these, we'll know that it found at least one path to the end. That's just going to be the first one that it finds. It's not necessarily going to be an optimal path. So it's going to keep printing until it exhausts its options. And yeah, I don't think this is fast enough. Let's let it run for like 2 more minutes until 8:25, and then maybe I can start work on sorting while it's running. It shouldn't be hard. I already have sort algorithms. Oh. Okay. This at least end state is there, so I shouldn't have to change this from last year. And then, oh, it works on global variables, so it shouldn't have any copy performance overhead. How are we doing? No progress. I don't even have median of 3. It might be good enough. I should be able to do this without a loop, but I don't really want to touch this because it worked last year. There's still going to be a loop, but the loop will be done in Fortran instead of in Syntran, so it might be a little bit faster if I do this with a slice. You're swapping 2 rows of a matrix, or 2 columns maybe, I don't know. But you don't really need a loop for that if you use a slice. I don't know what the optimal frequency here is. That's a hard problem to answer. You have to run it multiple times and benchmark it. Okay, and we've made, it's been 2 minutes, it's been 3 minutes, and we have no progress, so I think I have to try sorting. Oh, this is, yeah, we're gonna need a return here. Okay, yeah, let's try that. Okay, so it's sorted. It's sorting periodically. So we know it's making iterations. And if this is too slow, we can also try only searching the junctions. So it like kind of compress the graph. Right now we have a graph. Let me cat the test input. I talked about this at the beginning of the stream. We have a graph where each position, including the starting position and every dot, is a node in a graph, and we're searching that graph. So it's not too bad in the test input, but you have like a row of 3 dots, and within this row, there are no forks. If you start going to the right, basically you can only continue going to the right. So we could compress this graph by saying we have a fork here, and that's 1 node in the graph. Then actually that's not a fork either. We have a dead end here. So maybe the dead ends count as a node in the graph, or maybe we just prune off the dead ends somehow. So there's a fork, and then like here's another fork. So these would be nodes in the graph, but then this wouldn't be a node in the graph because it's just between 2 forks. So then we would have a graph with much fewer nodes, and we could search through it faster. And it would become a weighted graph because you're not just moving a distance of 1 and adding 1 to your score to get from this node to this node. So your distances have to be modified accordingly. I think I need to do that. I could also play around with the sort frequency. I think I'm sorting too frequently. In fact, I'm going to kill that. And let's bump it up to 3,000. That's what I used last year. It's a totally different problem than last year. So if 3,000, I don't even know if 3,000 was optimal last year. I don't know how thoroughly I benchmarked different sort frequencies. But even if 3,000 was optimal last year for that problem, it's probably not going to be optimal for this problem because it really depends on what problem you're solving. Also, we added in this sorter. So do I still get the right answer for the test input? It's like 7036. This might not sort at all. I think it says it does it once, but it might just be sorting on the very first iteration. So I don't trust that. Let's bump down the frequency again. Might need to be... What if we sort like every 10 iterations? I think we're at least going to hit 10 nodes in this graph. Okay, so that sorts a bunch of times. And it's the same speed. 7036, I think that was... Okay. So we still get the right answer, and I think I changed this to 3,000. That's the whole thing that I wanted to do. Okay, so let's let this run for a while, and then maybe I need to compress the graph. Also, we don't need to be looking at hash marks. The very least that you can do is only iterate over dots, and I kind of do that, but... Every time I'm iterating through neighbors, I'm doing this, the wall check. So you could do that outside of the loop and have a proper graph data structure. And then you would never even consider running into a wall. Okay, so while that's running, I think I can start working on compressing the graph. So the start is going to be a node, and the end is going to be a node, and then every junction is going to be a node. And yeah, and then sort of by definition, there's only one path from a node to a neighboring junction. So we have to get those distances. Like we have to say, here's a junction, and then what's the distance or what's the score that it takes to get from here to here? And then is a junction just its location? Or is it also the direction that you're facing when you get there? That makes this complicated. Anyway, we can find the junctions. And you don't need Dijkstra. You could just... I think you could do one flood fill of the whole graph with depth first search to find the junctions. And then I'm going to need to like entirely rewrite my Dijkstra implementation to work on the compressed graph instead of the dense graph with every point as a node. Yeah, this is going to be a part 1 only day, if I can get part 1. At least it's sorted a few times. It hasn't found the end at all, but at least it's sorted a few times. All right. I think I have to back this up again. cp main.syntran main. I already have v0. Now it's v1.syntran. Okay. I'm gonna have to run it over here too while the other one is running. How's my system doing? It's cooking. 100% CPU. It's using a decent amount of memory too, over 1%. Seems somewhat stable. So at least I think I don't have any memory leaks. Last year, I ran into a couple memory leak bugs where if I had a long running problem, it would just, I don't remember what the bug was, but the memory usage would just go up and up and up, and it crashed my stream a couple times from using too much memory. It just killed my Twitch stream totally. Okay. Yeah. Let's work on... So this was wrong. I can clean this up before I even start compressing the graph. Don't need that. Just do a whole slice. Yeah, already said min heap now. I can clean that up. Lots of stuff here can be cleaned up. Do I want to leave this in? Because I'm going to have to re-implement Dijkstra basically on a different graph. This is a one-liner. Don't need brackets for a one-line if statement, or braces, I mean. I think we don't need that. I got the right answer for the test input without it, so I think I don't need it. Again, I'm going to leave the Dijkstra pseudocode there. But then the next commented block below that. This is not Dijkstra. This is when I was thinking I could do it with depth first. But I don't think that's going to work today. Because depth first can't really find every path in a graph. It can get you to a place. But if you want to look at different paths and find the optimal path by some score, depth first isn't going to work. Breadth first can find you the shortest path as long as your weights are all 1. And then that's what Dijkstra is for. It can find you the shortest path when you have a weighted graph. I forgot that at the beginning of the stream, but now I've looked it up, so now I know it. Okay, let's compress the graph. I think... Do I still get the right... Yeah, I'm going to want to do this on the test input. Times syntran main.syntran. Takes like 5 seconds, but now 2 things are running, so it takes a little longer than 5 seconds. Okay. That's still the right answer, 7036. To double check, yep. Should I check the other example? I think I have to... Whoa, we have progress. Should I just see if this is right? Because like it might like continue searching, looking for other paths, but this might already be the optimal path. Is that the way that Dijkstra works? It tries to find things that are good first. I think it's worth a try. We'll have a generous timeout here between puzzle submissions or answer submissions. Oh my god. How long? I have no idea how long this has been running. Okay, 8 minutes. Might have to do that for part 2. Let's see what part 2 is about. This might be a part 1 only day. I might not be smart enough for all this. Bathrooms. Do we just have to backtrack the path? If that's all I have to do, I can burn another 8 minutes while it runs without optimizing anything. Any? What do you mean, any best path? Oh, come on, man. So I think the way that this works is this probably, I can try it on the test input, but it prints the progress whenever the progress is better than anything we've seen so far. It probably finds this number twice, or however many times it exists. That's why it keeps running for a while after it finds it for the first time, because it's still exploring options. So I think I'm already finding multiple paths. Or am I? Previous. So what the hell? How does Dijkstra work here? Should be the test input. Okay, that's the test input. So I said we don't need this, but if we have to know where the path goes, we're going to need this data structure. It's just another array. It's like, is it going to be the shape of visited or the shape of dist? I forget. I think it's the shape of dist. But can this get us all of the paths? Alt. Alt is less than dist. Where? Did I just fuck up Dijkstra? I think I fucked up Dijkstra. I forgot to do this part. Yeah. Maybe that's why it was so slow. I think it's worth to try that. I have to back up because I don't know what I've changed. V2? Okay, that doesn't exist yet. If alt is better than dist, then we push it. It's kind of embarrassing that I forgot that. I'm used to doing depth first, and in that case, you just unconditionally push. You still have to bounds check, and you have to check that you're not hitting a wall. but this is like the thing that makes Dijkstra fast, and I forgot to do that part. Alt. So if dist less than am I shadowing? I have an array for this. Yeah, this is an array. And then I have a shadow of that array. Why the fuck did I kind of forgot. I almost never intentionally use shadowing. And if alt is less than dist, what the hell is in my dist array? It's position, position, direction. X, Y, dir. Will this still get me the right answer for my test input? Is it any faster? Maybe not. File. What the fuck? iFile. Deleted too much there. Yeah, I'm not going to wait possibly 8 minutes to see if this is not any faster. So what am I doing? Yeah, I'm not going to wait. Alt. So does this find all paths or does this just find one path? See, with Dijkstra, it's tacking things onto this previous array. So Dijkstra can find you the best path, and not just the distance, which is all I needed for part 1, but like the actual path. You get that from prev or previous, prev. Does it find all paths, and can I easily modify it to find all paths? Well, we have the direction in here. No. It's easier to look at this. So the fork, oh, there are multiple forks. So 1, 2, 3. I think there are 3 different paths here. So after this point, there's only one. There are no more forks. So you can get here facing different directions, but eventually you're going to get here and turn right. So yeah, Dijkstra is not going to find all the paths because there's a node in this graph that says you're here and you're facing right. And there are 2 ways to get there. You either got there and you're already facing right, or you came up this way and then you turned right. But either way, there's a fork here when you're backtracking, you could go 2 different ways. So previous is not going to work like that because it will only backtrack one path, and you can't fork to have multiple equally optimal paths. Dist. Oh. I forgot about that part. So dist. How did I... Still got the right answer for the test input somehow. Is that's what's gonna make it faster. It should. Okay, that's like twice as fast. It was 5 seconds. Now it's 2 seconds for the test input, and nothing else is running right now. I mean, is it going to be 4 minutes? I don't really feel like waiting around 4 minutes either, even if it is twice as fast. It might be more than twice as fast. I shouldn't get my hopes up too much. But yeah, I can't really afford to... I can't be streaming all night. I'm going to have to call this soon. I could compress the graph, but then I still have a problem. Yeah, like I think this is solvable without... It shouldn't be slower than part 1. But I have to be able to find all the paths, not just one. So that's the hard part of part 2. Let's start by finding one path. So let me copy part 1 and make that part 2. Okay, so I need prev. Let's see if I can at least find one path. And worst case scenario, you only have 3 options of the fork. So if you came in from one direction, you could go out 3 different ways. So I think we need prev, but like prev with that's 3 times as big, because you could have 3 forks at each node. I'm gonna say -1. And what's the size of this thing? It's not really nx by ny by nders, because then this also needs to contain the state. So n state, that's like to get one path, you need this. But if we have multiple paths, let's make it 4 just to be safe. Could have a fork, so this is going to control like which fork you go through. And then we also need to keep track of how many forks there are. So this one, it's just going to be that size. But this one starts out as 0. And then this is like undefined. I'm just using -1 for undefined, because if I try to index a position by -1s, it should crash. Okay. Then actually I want to make this a less than or equal, because we want to find all of the paths, not just one. If it's the same length, I want to push that. So what does Dijkstra do with prev? So we initialize it to undefined. This is part 1. So we initialize it to undefined, essentially. And then whenever we update the distance, we also have to update prev. So what did I do with this? I don't just have prev, but I have nprev. And nprev, I think, is the same rank as dist. So nprev xy dir plus equals 1. xy dirs. Okay. And then prev has a couple other indices. So prev, nprev, so the first time we update this, we're going to fill in entry 0. And then the whole slice maybe I want to transpose these two indices, but it's kind of late, so maybe I'll just leave it like that. Small performance downgrade, possibly. Maybe nothing from not transposing those. Basically, leftmost is innermost, so when you can, you want to have your colon slice as the leftmost index of anything that you slice. Same way with your loops. That's why I usually write my loops with y first and then x innermost, because x is the innermost index, or leftmost index, and it's the innermost loop. So leftmost is innermost. That's the mnemonic to remember how to address your memory in a performant way. Same way that Fortran works. And then if you have a language that's like column major instead of row major, it's the opposite. In that case, rightmost index should be the innermost loop. So you have to know your language. Yeah, so n state, and then the same indices that we used here, x, y, dir equals, we're going to fill in end state things. So that's everything that we popped. It's going to be dist x, y, dir. Dist x, y, dir of the previous thing from the stack. Dist u, so v and u, and actually it is u. I don't need to remember which order these are. So I think I can just say u. I haven't like overwritten u or modified u, have I? Okay, I think that should work. Does this compile? I want to comment out part 1 because it does take 2 seconds to run, almost 3 seconds to run, even for just the test input, so I want to skip past that. Oh my god. I have to write another graph search now because we have forks going back. We got to the end, then we have to backtrack from the end along the previous best path node. So why is this running the real input? And because there are forks, that is now another search problem. We just have to iterate all the paths. So this is part 2. That's part 2. And now we have to do the backtracking. So we have to go from here. We have to follow. We start at the end now, and then we find the previous node of the end. And I think we come up this way. So we're going to be at this node, and then we say, what was the previous node of this node? And that takes us here. So that's how the previous data structure gets you to backtrack the optimal path. And before I fork all of them, I can try to just find one of them by always doing index 0 here. So, we can just modify chars. How do they mark this with O's? I can just put O's there. Just going to do one optimal path, not all of them. So which direction are we facing at the end, though? I think I have to keep track of that. I need another variable for that, because that's part of my state. You have position, but then you also have direction. So I have to know which direction was I facing when I got to the end. And then whenever I update this, I want to update dir end. And this is annoying. We're going to have to do this the verbose way, because we have two things to update. If dist not less than... We might have multiples of these too, so that's kind of a pain in the ass. Less than or equal. And then dir end equals dir not, whatever. And are we getting there with multiple directions? Like, it never happens in the examples. You always go up. You're always going up to get to the end. But there is this nice looking path there. Like, could we get to the end going right? And then that complicates my forking. Print that to see if there are multiple paths to the end. So I should have dir end now. Okay. So start at the end and start in the direction that we ended up at the end. And then we backtrack. I don't know why it indented like that. How do I do this? So okay, I think I have to have temporary variables. And then x equals previous. We're going backwards, so we get the previous thing. 0, we're just going to find one path for now. So n iterates over all of the possible forks in the optimal paths. So we're just going to do one fork for now. And then if we can get that, then I might try all of the forks. And what is this? So you have to keep track of where they are in the state. So x is at 0. X naught, y naught, dir naught. And then y is at 1. And then dir is at 2. So managing state is hard. Could have just done this with a whole vector. Yeah, and then I could have done this with like one line. But it's fine. I already wrote it now. If we get to the start, we're going to break. Technically, I think we need that condition because your first move might be turning. But that doesn't change. They just want to know how many tiles are on one of the best paths. So I think it doesn't matter for part 2. But if you had something that depended on the direction, you might want to backtrack in that way till you get at the starting point and you're facing in the starting direction. It's not important here, but it, you know, if it was a different problem, it might be important. What a meaningless thing to say. If this was an entirely different problem, you might need entirely different code. Of course. I've been at this a while. Maybe I should call it at some point, but I feel like this isn't that hard. If I can get one path and then I can just iterate through all of these zeros, I should be able to do all the paths. And it's going to take 10 minutes to run unless I compress the graph. And I think it's faster to let it run for 8 minutes than it is for me to write that graph compression code. Why? Okay, yeah, that's the test input. What? I think... Do we have an infinite loop here? Backtracking. Are we getting here? It should only take like 2 seconds to start that part. Because part 1 took 2 to 3 seconds. Why is that an infinite loop? While true, break. Previous. I guess I'm not setting previous correctly. Why? Why not? Ooh, boy. Why did that crash? I added a print statement and it crashed. Something... Okay. It went out of bounds pretty quickly. How did that happen? That's not right either. That's also out of bounds. 13.1. 13.1. Dir end. Did I not get dir end? Sorry, I'm using a mouse today. Usually I just use the trackpad, so sorry about all the noisy scrolling. I do like the feel of the mouse, though. -1. Dir not. Should be defined. Is this not like negative or anything crazy? What the fuck? Okay, it's 2. That's a valid value. And then it just goes crazy. So I think I didn't set prev correctly. This is probably part 1. This is part 2. Nprev. Did I use nprev correctly? So in the pseudocode that I copied, whenever you update dist, you also update prev. So dist is updated here, xy_dir. xy_dir. Then we increment it. Dist is alt, prev is u. Why doesn't this work? I feel like this is an attainable problem. If part 1 would have taken longer than 8 minutes, I might have given up there, but I feel like I should be able to get this now. By end state, so because there's a slice here, we have the whole state. X, y, dir. So what the fuck? X is x end. It's like they're off by 1. We have a 13. Then we have a 13 where the y should be instead of where the x should be. Does the... Yeah. Because u has dist. Oh, okay. So this is actually 1, 2, 3. I think I was setting it correctly, I just wasn't backtracking correctly. There we go. Okay, so that should be one path. And can I visualize this? So chars x, y equals O. I think that's not going to mark the start. Or it won't. No, I think that should mark all of them, including the start and the end. And then can I print that to visualize it? Excuse me, Jesus. I might have an off by 1 error where it doesn't mark the start or the end. Yeah, so start is not marked. Just have to mark that. You have to have this line twice somewhere. So that's one path. I've backtracked. It takes 2 seconds to run. I've backtracked one path of O's, but now I need to get the forks. So that is another graph traversal problem where we have to find all the paths. So I think I can flood fill, right? Oh my God, I have to write another stack algorithm. Why do I have to do this twice today? I don't know. This is kind of a fun problem. So this is how you do it with 1. V3. I had V2. V3. Okay. First of all, part 1. Keep getting confused in part 1. I think I can at least delete the Dijkstra pseudocode from part 1. If it's in part 2, I don't need it in part 1 as well. Every time I copy a backup, I feel a need to clean up. Okay, so I need a comment. Equally, I feel a need to specify that paths that lead from the start to the end. Nprev is incremented to track this. Okay. Well, we didn't need it for part 1, but now we need it, so that comment is out of date. Yeah, keep this here for now. Maybe I'll get rid of it eventually, but I'm not ready yet. I'm not going to want to log that all the time. We'll see in the visualization if I get all the paths correctly. So I think less than or equal is important there. So if we only had one path to find, we would not have a slice here. Or we would not have an index here. We would have one less rank in this array. And then you wouldn't have anything to increment here. So because we need all the paths and not just one, you have to increment this thing and then set the corresponding part of this array. And then if you only wanted to backtrack one path, you can do it like this. But to backtrack all paths, I'm going to want to... So the fact that you can end facing different directions, it's kind of a pain in the ass. I think I have to push 4 things to my stack, at least 3. Well, you can end facing right or you can end facing left. But those are your only 2 options. Well, let me look at the real input. E, yeah, I think it's in the top right. So I think you can only end facing up or right, or north or right. Yeah. If it was somewhere else, you could potentially end facing in 4 different directions, and that would complicate things even more. But we only have 2 options here, so it's only half as bad. So I'm going to have to push those 2 to a stack, and then search backwards through every index here, not just zeros, but all of the valid indices up to nprev. And then that will find me all optimal paths. Okay, so I want to push those onto a stack. And what? It's just X, Y in position. So it's 3, I think end state is 4. I think I should have another variable that's like end state minus 1. So I don't have this magic number 3. So it's 3 by stack cap. And stack cap, I think, is that the maximum number of points that you could have? Might be more than that. I don't know, just to be safe. Maybe you can get there facing different directions, so let's add a little buffer, or a lot of buffer. So we're gonna push 3 different things to the stack. So you can end facing north or east because the end point is in the top right. For my input, at least. I doubt that yours is different, but could be. I don't really know. So we're gonna push 2 different things there. So stack SPTR. We need a stack pointer. No, it's gonna be a slice and then S pointer, and stack pointer is gonna be 0. So we're gonna push X, E, Y, E, east. I said north in the comment. I said north first. So north, then increment the stack pointer. That's how you push. And then we're going to push the other one. So X, E, and Y, E again, but this one's going to face east. And then we iterate on the stack. So that's actually going to be while stack pointer is greater than 0. This was the single path version. So let's not do that. So we're going to pop, and then we're going to push all of the previous for every index of previous. And that should just iterate through everything. And I think I can finish part 2 here. It's going to take like 8 minutes to run once I get it, if I get it right for the test input. And I think we're going to find that out shortly. So we're going to pop S pointer minus equals 1. And then do I want X naught or just X? I think X naught, because X naught is what we pop, and then we're going to find its previous, and that's going to be X, and we're going to push X. So I want X naught and X still. So it's going to be stack 0 S pointer, stack pointer, and similar for Y, and then dir naught. Now I have to indent. Could be D naught, then everything would be clean. Dir naught is slightly more readable, maybe. And then we want to iterate through all of the previous's. And we probably want to mark. When do I mark? I might have a different off by 1 problem here. That's fine. Okay, so I want to mark X naught, Y naught equals O, and we're going to count the O's at the end, and that's going to be the answer. So then instead of this, I want to mark XS, YS. That's, you have to have this twice, either before the loop and in it, or in 2 places, in the loop or in the loop and after. I think I picked the right one because this is easy. Okay, so we mark, and then we have to iterate through all of the previous's. And then there's not going to be a break. The loop condition is stack pointer. The stack is not empty. Nprev. Now it has 2 less indices here. X naught, Y naught, dir naught. So we're going to push stack unpack. I'm going to unpack from the previous array. You could just use the array directly, but I have to do this for my sanity. But this is now I, because we're iterating through all of these, not just 0. That's how we find multiple paths and not just one optimal path. Yeah, because if I didn't do this, I guarantee you I would have fucked up this 1, 2, 3 indexing that I made that mistake 20 minutes ago and had to spend some time figuring out what was wrong. I didn't think the problem was here. I thought the problem was like up here somewhere where I was setting prev, but it wasn't that. I had 0, 1, 2 here instead of 1, 2, 3. You could have like another enum that lets you use enums instead of magic numbers as indices, but it's too late. I think we're almost done here. Okay, so we're pushing the stack. It's going to be x, y, dir. And then increment. I think that's basically it. So we mark, and then I think the answer is going to be count chars equals O. That's how I count things in a matrix. There's this built-in function called count that does that. So let's see if it gets the test input right. I'll be optimistic here and not save a log file. So there should be a couple forks in here, and that did not work at all. Apparently didn't do anything. How did it not get the end, at least? Like that one should be a O because I think I'm gonna have to debug inside the loop. So we pushed 2 things onto the stack. Am I like breaking when I hit the end? I don't think I have any breaks or continues here. If visited. So is nprev 0? All right, what am I popping off the stack? At least 2, hopefully. That's not good. What the fuck? Okay, direction is 13. That's not good. Right. Duh. I'm feeling good about this. Hey, look at that. We got the forks. Okay. And then 46. I think that's right. 64. Oh, that's a different example. 45. What the fuck? Off by 1? What? Are you fucking kidding me? Did I add? Do I have to count these manually? $45. What the fuck is... Oh, I know. Yeah, because we pushed 2, but I don't actually know that there are 2 different ways that you can get to the end. So... I have to check that this is valid somehow. Because we had, how did I initialize prev? I think I initialized it to -1s. Yeah, so in Dijkstra, you're supposed to say undefined. So if I have a prev that's a -1, I don't want to process that one. I think that's what happened. So I got an extra O up here, which shouldn't be there. The fuck? Oh no. Well, worst case scenario, I either get the right answer or I get the right answer +1. I think I just have to start the run. And then if I have to submit the answer twice, so be it. I think I got it first try on part 1, so probably that's not too much debug output. It's only going to be the optimal paths. There shouldn't be that many forks that get logged there. So I'm going to start that. I need a short break. I guess I'll be back within 8 minutes. Oh yeah, we changed the Dijkstra to compare like the alt, if the alt is less than the distance. So this might be twice as fast as part 1. I don't know yet. I haven't let it run until now. So I guess I'll be back in 4 to 8 minutes or something. Yeah, I'm going to take a break and let that run. Don't want to stop streaming, but I think I want to definitely turn my mic off. Yeah, let's mute this. Hold on, let me confirm that I'm muting. Okay, test. All right. Is my mic back on? Cool. Hey, it's backtracking. I was about to feed my cat, but we should basically be at the answer by now. That's logging a lot. I did not think it would log that much. It can't... Shit. Could there be loops? Oh my god, there might be loops in the backtracker, so I need a visited array for backtracking. I also should feed my cat soon, but I kind of want to start a run since it takes a few minutes. Yeah, there must be 3 122 2, 3 122 2, and then 3 122 2 again. So I have loops in my backtracker, which I didn't have for the input, so I need like another visited array. Backtrack. V4. I'm not going to commit all these. I'm just going to commit one whenever I get there. Maybe I should just be committing. But I usually do one commit per stream unless I have to sleep on it. How long did that take, by the way? Should have done that before I started it again. Took 5 minutes, so I don't know how long I let it infinite loop, so maybe it was twice as fast as my first cut. What I really need is the graph compression. That should make it way faster. Okay, so test input, and then I need to get rid of the loops. And there are no loops in the test input because this did not have any issues. Like it looks like there's a loop, but they actually only go in one direction. But if you had multiple paths that like crisscrossed in a way that could possibly create a loop, then that creates issues for me. So I think I just need a visited array. So one of these shouldn't be pushed, at least for the test input, and I think there's a way to figure that out, but I don't even have a time to write a longer comment right now. Just want to get this working, and then I mean no, it doesn't have DIRs, so I already have, okay, I can just reuse this array. Visited. I feel like it should be a different array though. Okay, and then I guess I'm going to do it after here because I want to make sure I mark it, but it probably could be like up here. Might have bounds issues. That might not do anything. I was trying to fix this, but that's not the way to fix it. So if visited x not, y not, dir not, continue, otherwise visited x not, y not, dir not equals true. That should fix the infinite loops, I think. Let's at least make sure it still does the test input within one of the correct answer. I'm not going to say do it correctly because it's wrong, but it's close enough that I should be able to do 1 or 2 submissions here. All right, so that's going to take another 4 to 5 to maybe 6. It was 5 minutes and change, but I don't know how long it infinite looped. So about 5 minutes. Yeah, I'm gonna feed my cat. I'm not gonna bother muting this time. So I'll be back. This will only take a minute for me to feed her. Okay. I have no idea what the progress is. I remember when I ran part 1 here, I mean, it prints this pretty much immediately, but then it ran for a while before it printed. What was my correct answer? Not this window. What did I submit? 73,432. It printed that, and then it kept iterating for a while, but not that much longer. It was like within 30 seconds or maybe a minute after it printed that when it finally finished. So there's not any good progress indicator here. I don't know how you would make a progress indicator for Dijkstra. Progress bars are hard most of the time, and I think Dijkstra is a case where it's very difficult. There's probably some estimate out there of how to guess how much progress you've made on Dijkstra's algorithm, but I don't know how to do it. I tried, but it tells you it starts, and then it tells you that it's basically done, and then it's done. So let's hope that it doesn't loop infinitely this time. Yeah, I've been at this for 3 hours. It took me a long time to get started on part 1. It was like maybe an hour and a half before I even ran my code today, because I started doing, I don't know, depth first search, and then I was like, oh no, hold on, that's not gonna work. I have to do Dijkstra. And then I had to look at my code for Dijkstra, and I had to look online for Dijkstra, and I had to decide like which one I wanted to copy, and then I kind of ended up copying from both. I think we're getting into, oh, I think it's almost done. I really want to do the graph compression. I don't know what the term for this is. It's just encoding the graph in a different way. I really want to do that, but I think I'm too tired to do it tonight. I'm definitely not going to do it on stream if I can get an answer here. And then, you know, tomorrow might be just as hard as today, so I probably won't have time to do it tomorrow either. And then by the time the weekend gets here, there's probably going to be like 5 other things that I have in a backlog of things that I would like to optimize. Oh. There goes a microphone. It's okay. Sorry about the noise. I don't know how noisy that is. Should be pretty close here. I've got to, it's like 50-50 whether it's off by 1. Actually, I think I did not save a log, but I can look at this, and then I should be able to tell if it's off by 1 just by looking at the character output. Oh, come on, T-Mux. That's painful. Oh, come on, keep scrolling. I hate this when you try to select and it should scroll, but it just like doesn't want to scroll. Got like 800 lines to go. Keep going. Okay, can I just hold the mouse there? And will it keep scrolling all the way? I could have just submitted it twice at this point. I should only have to look at the first row. Probably. Okay. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. Comma space with nothing. No, comma space, nothing G. There we go. Okay. So where... Yeah, it's definitely off by one because this path leads to nowhere. It actually leads to a dead end right there. For my input, yours is probably different. But you can tell the O is next to the dot, so that's definitely one greater than the actual right answer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I think it should be 496. 496. Oh, that's probably the longest I've ever spent on an Advent of Code problem in one stream. I built on a lot of code that I wrote last year and just copied and pasted here. So if I saw this problem last year, I would not have gotten this on stream. Man, that was a doozy. It's always hard to tell, like, was today hard or has it just not been long enough? Because more people, I took, 22 hours after the puzzle was released to solve this, even though I've only been looking at this problem for 3 hours. Other people are going to look at this for the first time later than I did, so you're going to get more people rolling in here. But also it is difficult, but like right now, you can't tell from the stars, was this a hard problem or is it just too soon to tell? Day 1 and 2, well, I don't know. People who go back and do previous years, they probably start at like problem 1 and 2, so you're going to have new users roll in there too. What if we look at 2023? Can I even see stats for 2023? Yeah, okay. Yeah, so there's a clear trend, like the first day is easier and then they get harder as you go. And, sometimes there's a non-monotonic bump. This one, day 15, might have been a little bit easier. But for the most part, they get harder as you go. So if you look at like 15 to 16 last year, it was only a 1-star decrease in terms of like each star represents 9,000 users, 8,000 users, if I round correctly. So this is off by like 3 stars at this point. I think we're going to get like 2 more stars worth of users, 18,000 more users roll in here. Or maybe 16 was just significantly harder than 15. 15 was hard too. Yeah, I forgot because I did this at midnight. And then I had to sleep on it before I could get part 2. I thought part 1 was not hard on day 15. Terrible rank, but during the week I start these on the East Coast at a bad time. I'm not doing them at midnight anymore. I would not have wanted to do this at midnight. Can you imagine if I was up until 3 a.m. working on this? I would not have gotten it either. I would have been too tired to do what I just did today. Okay, let's commit. I don't think I'm even going to clean up the logging yet. So I think what you want to do here, I think you want to check if dist equals dist end, because that will tell you if it's part of an optimal path or not. Wait. I don't know if this should work. But it did work. It was off by 1, but I think other points should have the same problem that I have at the end point here. I don't know. I don't really understand Dijkstra. Dijkstra is like magic to me. I can never write Dijkstra off the top of my head. I always have to look at Wikipedia or look at my old code, which I originally copied from Wikipedia. I think that's the way to fix that off by 1 error, because it's pushing one that's just a dead end path. One of these is good, but the other is a dead end path, and I think you can do that by looking at dist xy dir maybe the input is carefully crafted so that you only end up getting to the end by going north, never east, but not for my input. I don't know how other people's inputs differ, or if it's just carefully crafted. I don't want to mess with it. It took almost less than 5 minutes. It's not terrible. I really want to do the graph compression, but I don't know if I'll have time. Yeah, like I don't want to touch this too much and then risk breaking something that takes 5 minutes for me to tell if it's correct or not. So I'm not going to do the cleanup right now. And then all this stuff can stay untracked. In here, I just put some comments. Now that I've passed by reference, and I've basically released pass by reference as a source-only release. I'll do a binary release later this month, probably. But there are a lot of things in my utils, like sorting, that could be done with references instead of copying values of large arrays. Oh, and then, yeah, I added this to utils. And then I have cat strings. I think I want like a print matrix function that takes a matrix of characters and prints it without the commas and comma and space delimiters. because then I could like debug and log this, but without all of the delimiters. I do that frequently, and it would be nice to have a helper function to do that. Okay, I think I'm going to commit and push and end this. And nobody's watching, so I'm not going to bother raiding. Okay. Not gonna commit that yet. I'll commit something else soon enough. Yeah, that's it. I just copied my code from last year, so I'm using queues as a global variable. Now that I have passed by reference, I could just pass a reference to this queue around and not have it as a global variable. And I have structs, so you could have the queue array and its capacity and its beginning and end indices all packed into a struct or encapsulated into a struct. And then you don't have to have these loosely related variables that are just implicitly related by their names. And then you could cleanly pass a reference to that to a function to like push to the queue or pop off the queue without relying on global variables. But I copied this from last year, so it's not done cleanly right now. Like the sort queue function just sorts the global variable. It doesn't take any arguments or return anything. It should take a reference and then just modify that reference to the queue. But I only added that feature yesterday, so I have a lot of code that doesn't work like that. It doesn't work the way that it should. And push and pop should also take a reference to a queue. And there's part 1. Part 2 wasn't too much harder than part 1. It's just, it takes 5 minutes to run, so that's inconvenient. The only difference is that we added prev and nprev. This is not in Dijkstra, by the way. You only have one prev. You don't have like multiple previous nodes for each node. Does it say anything? Yeah. All shortest paths between source and target. Okay, so that's exactly what I did. Yeah, and then you have to do a depth first search to backtrack, which is exactly what I did. I used a stack, so that's depth first. You could also do breadth first, and then you would need another queue. Not the queue that I had in this code, but like a different queue for the backtracking problem. That's a different commit. Here's today's commit. So part 2 is just adding these two things. And then you have to, after you initialize them, you have to set them in here. If you only had one path, it would just be one line. But because there are multiple paths, you need an extra dimension here. And then backtracking, I don't know, writing a stack-based algorithm to do a depth-first search. That's like, I can do that without too much trouble these days. I've already done that for several Advent code problems this year. I think that's pretty much it. visited. You could just like count. You could count visited instead of counting characters. Didn't realize that I would need this for infinite loops because the test input worked without an infinite loop problem. Oh no, but visited has like this extra dir direction, so you really do need chars or some other Boolean array that's one less rank than visited, because you only care about the position. You don't care about the direction for part 2, at least for the backtracking part. Yeah, that's gonna be it. Thanks to everybody who tuned in. I'm super tired, so I'm gonna end this stream. Bye.